Hey guys, so today we're going to talk about what hydrates are and how to name them, how to do a little bit of math with them. So let's just go ahead and get started. First of all, what does that term mean? What are hydrates? So hydrates are compounds that naturally absorb water from the air, so they absorb moisture, okay? And then if we heat these compounds, the water can be evaporated. So here in this picture, you have an example of a copper sulfate ion that has absorbed 1, 2, 3, 4, 5 water molecules. Okay, you may have seen these in medicine. Sometimes they come with little packages in there. A lot of times when you buy electronics, they come with little packages in there. Those are there to absorb moisture from the air to preserve the medicine or the electronic or whatever it is. Okay, so here is an example of two different hydrates. So how do we name a hydrate? You're going to have some sort of ionic compound here in the beginning, and you just name that like you normally would any ionic compound. So this is magnesium chloride. Okay. Now you see this dot here. This dot is not a multiplication sign. It just means that that magnesium chloride has absorbed 6 water molecules from the air. So think, this isn't a good analogy, but think of like a shirt getting wet and then you could dry the shirt, right? So that's what we're talking about here. So magnesium chloride with 6 water molecules. So 6 is hexa, and then water for this, we just call them hydrate. Okay, so magnesium chloride hexahydrate. Try to pause the video right now, see if you can do the next one on your own. Okay, so let's try the next one here. This is an ionic compound. Of course, we have a transition metal, so we have to put its charge in parentheses. I won't go over that in detail right now because hopefully you already know how to do that. So this is iron sulfate, and then here we have a 7 water molecules, so that's going to be heptahydrate. So these prefixes are the same ones that we use for covalent molecules. So mono, di, tri, tetra, penta, hexa, and so forth. Okay, so that's pretty much it for naming. Let's talk about molar mass. How do we find the molar mass of these guys? Well, for the first part, you would add 1 magnesium and 2 chlorines like you do anything else. So for the sake of time, I'm going to tell you that magnesium chloride is 95.20. But then we have to add, and this is what's confusing, we are not multiplying, we are adding 6 water molecules which have a mass of 18.02. Okay, so that is 203.32 grams per mole for the molar mass of this hydrate. Okay, so pause the video again, see if you can do the next one. Okay, here we go. So this part here is 151.91, and then I'm going to add 7 water molecules, which will give me a mass of 278, oops, there's supposed to be a 7 in here, 278.05 grams per mole. That's pretty much it. We're just adding 7 water molecules to this initial part. And then the last one, how do we find a percent water of a hydrate, which is the same thing as percent composition? So for this one, I have 6 water molecules over the whole thing. Okay? Over the whole thing times 100. All right? So when I do that math, I should get 108.12 on top divided by 203.32. This didn't give me any sig figs, so I'm just going to round to the 100th place. 53.18% water. Okay, you try the next one, and then I'll put the answer up. Okay, so we've got 7 water molecules over iron 2 sulfate heptahydrate times 100, and that is going to be 126.14 over 278.05 times 100. Remember, it's always the part you're looking for over the entire thing, over the whole. And that should be 43.37%. Can't write in a straight line. 43.37% water. And that's all we've got to talk about for hydrates.